Perfect. And Francesco, whenever you want.
Okay, thank you very much. So, good morning, everybody. First of all, I'm so briefly presenting myself and what are the aims of this online training we are going to do in these 2 hours. So, my name is Francesco Molinari. I'm the director of Europass Berlin, and we are a training center specialized in new teaching methods for primary and secondary schools. And in particular, we are specializing now on the STEAM approach in all its implication in the educational process. That's why we are doing now this training. And so this training on STEAM is actually the second part, because it's a blended training, the second part of 10 hours training.
Okay.
And so the first part. Sorry, I suggest to mute their microphones, because otherwise I hear some echoes. Okay. And yes, of course. So this is the second day, the second part of the training on STEAM education, the STEAM approach in education, comprehensive training in which we can have an overview of the approach itself on the first part. And of course, I assume you have you had a look on our handout on the first day to have an idea. So what is the STEAM approach and how does it work? Of course, we can repeat a short introduction in order to understand which are the main features of the approach. And then today we are going to focus on the other methods, other educational methods, which we can be used also for implementing a STEAM lesson. I'm saying this because, referring to the first part of this blended training, STEAM is not a structured method like other ones we are going to see today. But STEAM is an approach in which we can use different methodologies in order to let it work better, in order to have a structure in this approach, which is so pretty free. So we can use really many different methodologies. We can integrate these methodologies to each other. We have plenty of possibilities, as we are going to see. But as I said, STEAM is an approach. And this approach is, of course, the main focus is to connect the arts, and arts are not only the figurative arts, yes, of course, also, but also music, dance, also literature, languages, so all humanistic subjects, with the STEM disciplines, so with the science, with the technology, with the engineering, mathematics together. And how to integrate these principles, these standards of subjects together. The most important thing is so the arts are not in service of the other content. What does it mean exactly? So I can make a short example, like just make a project and build something at the end is not enough for a STEAM lesson. It could be an important issue also by planning a STEAM lesson, so like to let students build a physical product, of course, but it's not enough. And why? That's because the most important feature of STEAM.
Tu pensi che io capisco questa che dice?
Sorry. The most important feature of STEAM is to integrate this art content in the lesson. So, for example, think about the evaluation. When we are going to plan a STEAM lesson, it's important, for instance, also to evaluate the art content and the scientific content addressed. This is, of course, really important also to foster the collaboration among teachers in the same school. STEAM is also a matter of collaboration. It's still difficult to implement STEAM as a single teacher, but my suggestion is always to implement the STEAM approach with many teachers, or if possible, in the entire school. Now I'm going to tell you what we're going to do exactly. So in this training, the first part will be devoted to the project-based learning approach and its connection with STEAM. How does it work, and why it's useful to implement it jointly with the STEAM lesson. Then we are going to analyze another structured methodology, educational method, which is the design thinking methodology. And also here, we are going to see together which also practical activities we can plan to make a STEAM lesson with our students. Of course, we will have also a brief overview on the assessment methods which we can use in a STEAM lesson, also in relation with the two other methodologies we are going to talk about. And finally, of course, we will have a Q&A session, because I know that's the topic. It's really difficult. I don't know if someone of you has already implemented some STEAM lesson or tried, but anyway, it's a long process, and it's a long process for all teachers and students. It's a complex approach, and also the other methodologies are quite complicated at the beginning. That's why it's important that at the end you have some time to ask questions and to find some solution together to your issues. Okay. Perfect. Now, so let's talk about together about project-based learning and STEAM. So as we said at the beginning, and as you can see, so in the first part of our blended training, so the STEAM approach, one of the main features of STEAM, and also one of the reasons why STEAM is a really good approach for students, it's that STEAM is always real life connected. This is one of the key features, the most important point when we are thinking about the STEAM lesson. We should have always a real focus in mind. What does it mean? For instance, we can think about the practical application of the content we are going to teach in one lesson, and that the students are aware of this practical application, because it's important also to motivate the students that they can see also the point of their learning. This is one also of the greatest advantages of STEAM. So to let the students see the point of their learning process, and it's a great way to motivate them. So STEAM is real life connected, and all the outputs, all the final products of the STEAM lesson should ideally connected with a real life use. For instance, build some products or do some performance connected to a real audience, or build some products that a real audience can really use in the everyday life. This is useful not only for learning, but also for people external to this learning process, external to this lesson. Of course, we are going to make many practical examples of this. I know now it's only theoretical, and it's difficult to figure out which outputs we can realize. But of course, we will analyze many useful practical examples. And of course, STEAM is an approach. Of course, we have proposed in the first part of the training, like a division in steps to organize and to plan a STEAM lesson. Also, in order to help the teacher to follow some rules, and also for the students to have in mind which is the focus in each different steps. But of course, since STEAM is only an approach, we need some methods to better implemented. And one of the most suitable or the best methods to implement STEAM in our classroom is, as we said, the project-based learning methodology. And now, of course, we will have a short overview of the project-based learning methodology, and then we will analyze the connections between the STEAM approach itself. So first of all, I would like to introduce you the project-based learning itself. What is actually project-based learning? So we can start from a definition of this methodology. Of course, project-based learning is a teaching method in which the students can gain knowledge and skills by working for an extended period of time. Let's focus on this definition a little bit. So the students will gain knowledge and skills together. This is also well connected with STEAM, because knowledge, of course, we talk about the content knowledge. For instance, so mathematics, arts, literature, whatever, the content knowledge of the lesson, the content you would like to deliver to the students. And skills together. Skills here refers to the soft skills, as you see in the first part of the training, or the 21st century skills. So project-based learning and STEAM approach together are really extremely useful also to, of course, transfer the content knowledge to our students on one side, but on the other side, also to let them develop these soft skills, which are, for instance, the critical thinking, the creativity, the collaboration, also since in part or also totally a STEAM lesson could also be a collaborative lesson. And the communication, of course, also because, as you remember, in STEAM, it's really important to share the acquired knowledge also to an audience. And not only these skills we are going to develop with STEAM and project-based learning together, but also the literacy skills. Also because the STEAM approach, one of the other key features of the STEAM approach, is to let the students research independently. Of course, with the guidance of the teacher, yes, but independently in such a way that they can develop also their literacy skills. They can develop also the knowledge how to get information, which is, as teacher, you know perfectly, this is really difficult now because the students, so with the internet, they have so many possibilities, much more as before, to get information. But of course, it's becoming more difficult to distinguish the information. Also, which are trustworthy or not, which are useful or not. With this approach, we can help the students a lot to recognize which information are useful or not, and where to find the correct information when they are carry out a research, for instance. So also for this reason, is project-based learning connected to STEAM really important. So we say that this teaching method, project-based learning, it's a method in which the students gain so both knowledge and skills, knowledge and competencies, by working for an extended period of time. That's because the project-based learning approach, it's you can implement it. So there are some ways to implement it also in one lesson, 1 hour or 2 hours lesson. It's possible, of course, but it works so even better if you can plan a longer lesson, like 4 different lessons or 8 different lessons in 2-3 weeks or 1 month. That's because, of course, as we are going to see, the project-based learning is about to solve also complex problems and with a lot of different knowledge and different skills related to the solution. And that's why normally when we are planning a project-based learning lesson, if it's possible, of course, we should plan it for an extended period of time. So not only 1 lesson, if possible, of course. And the aim of project-based learning is exactly to investigate and to respond to an authentic and engaging question, problem, or also challenge. What does it mean? That the students here in this with this methodology, they can or can also have previous knowledge on the topic. I explain it better. They have a problem to solve, and maybe they don't have the knowledge to solve the problem at the beginning. In this case, they have to develop, they have to gain this knowledge in order to solve this problem. And this should be a real problem connected to the real world, or a question which multiple possible answers, as we are going to see in detail later. But the main point, the main focus is only this. So solve real problems and answer to real questions. Real, I mean, so connected with the real life of the students. And also the same for the problem to solve. So this is the main definition of project-based learning. And also from the main definition, we can, from now on, have some useful insight how it is connected to the STEAM approach. So, of course, as we see, STEAM and project-based learning are both inquiry-based. This is the most important thing here. So both methods are inquiry-based methodology, because you start always with an inquiry, with a question, or with a problem to solve. Also before you have the knowledge to answer or to solve the problem. And it's a student-centered method. And this is also similar to the STEAM approach. Also STEAM, as we can see in the first part of our training, STEAM is extremely student-centered. And of course, what does it mean also? The teacher, of course, is important. It's even more important than in the frontal lesson, of course. The role of the teacher is fundamental, but it's quite different from the, we can define, traditional one of the frontal lesson. Because in project-based learning and also in STEAM, and also that's why these two approaches are strictly related. The teacher is not the that one who has the knowledge, but it's a facilitator. It's a mentor. It's like a guide. You are guiding your students to find the solution of the problem. They do research independently. They do solve independently this problem, but of course with the guidance of the teacher in each step of the process, exactly as in STEAM approach. In the 6th step of STEAM that we have seen, so in the first part of the training, the teacher is always present. It's always for helping, supporting the students by finding their ways, the independent ways to solve the problem or to do the research. So that's why also project-based learning is a student-centered methods, of course, based on projects. Of course, you can understand it from the name of the method itself, but also here it's useful to spend some other words about the concept of project, because why project-based learning? Yes, it's connected to project, but it's different to just carry out a project in class. Which are the main differences here? For instance, so you can do a project in class with the final output to build something, to produce a final output, a physical one, like a model, a 3D model, or whatever. But in the normal project, normally, you are just giving the instructions to the students. You have to build something at the end, then you give step by step the instruction to the students in order that they can build this 3D model or this artifact at the end. This is a project, the classical one, we can say. By project-based learning, it's different. And why? Because in this case, you are going to realize something at the end. With the project-based learning, could be a physical product or not. There are many possibilities, as we are going to see. But anyway, you are not giving the instruction to the students, but you are giving them just the input, just the question or the problem. And the students are going to find the instructions, which is the knowledge required to solve this problem or to answer to this question. This is the main difference from the normal, the projects at school and the project-based learning methodology. So that the students are going to find instructions by themselves. Of course, always, as I said, with the guidance of the teacher. That's always a point to outline. And of course, so we said, we have to solve problem or to answer to questions. But which kind of problems and which kind of questions, of course. Here we have to analyze, of course, some examples, but also to introduce what are the main steps also to implement a lesson with the project-based learning methodology. The first step is the collaboration. So students must be collaboratively engaged, not only in the realization of the final output, which can be the final product or final research or whatever, but they have also to be engaged in the planning of the lesson. What does it mean? That the students, ideally divided into groups, into small groups, should also plan which steps they are going to follow in order to solve this problem or to answer to this question. So which knowledge is required and where to get the information, and also how to put the information together to produce the final output. So also it's fundamental to engage students by planning the lesson. This is the same in the STEAM approach and the project-based learning. Also, that's why they are good, two good methods to be used together in connection to each other. Then, of course, it's also fundamental to help the students to plan the schedule with them. This is also a matter of time. You as a teacher have, of course, many different tasks and lessons to do. And here, of course, you can plan the lesson. I don't know, it depends on the problem, if it's complex or not so complex, or the question. If you can plan the lesson in, for instance, 2 or 3 lessons, divide, so the project-based learning lesson in 2 or 3, 1 or 2 hour lesson or more. Then you communicate it to the students, and then they can help you to plan also the lesson and to identify the different steps of the project-based learning lesson. Also here, we will repeat this later, but it's important to outline also this before to go much deeper in this approach. Also here, it's really, really important to that the students know that they are going to gain some content knowledge, of course, but also to develop some competencies, some soft skills. For instance, we talk about collaboration or also creativity. It's important that the students are aware of this and also that they can recognize the importance of these skills, because of course you can understand it so easily. If they are going to carry out a project or to produce a final output, a final product, in small groups, so together, they must collaborate in a proper way. So they must collaborate well in a group. This is also really important to motivate the students, also because it's a real life approach, because also in some of these methods, particularly design thinking, but also project-based learning part, are also used in a real life situation in companies to do projects and to develop new products. And of course, also in the real life, many students will work in teams. And it's really important that they know that the collaboration, it's important to be successful.
Sorry, Francesco, to interrupt.
Yes.
I just saw Pepe asked if you have any presentation to watch or if you're using a presentation that you can share.
Of course, I can share my screen and follow the presentation. I don't know if all participants have this presentation. This is one of the presentations we shared at the beginning, but I can also show it. I'm sharing the screen.
Thank you.
Now, just one moment. Okay. Now, can you see my presentation? Yes.
Yes.
Okay, perfect. Yes, we can follow this this presentation. It's the same you can find on the website. And here in these slides, we are now summarizing some of the main points which we're talking about by the planning of the STEM lesson with project-based learning approach. So we already said that both approaches are inquiry-based. And also the students can control their own investigation. As we said before, they are going to research independently. So as we said before, to find out the instructions to solve the problem. Another important thing, so the two methods or approaches have in common is that at the end, the students, the groups, are going to produce like a final product. As I said, so in project-based learning and STEAM, in this case, it's not mandatory that they are going to produce a physical product. It can be useful, of course, but not mandatory. It's important that the students produce but something in the end, something they can show, as we are going to see. Also, what we're saying about the planning of the project-based learning lesson is that the goals, the decision, also the solution are generated by the students. Also here, with the support of the teachers, also it depends on the grade of the students, of course. For the younger one, the role of the teacher by guiding them will be, of course, more important, but anyway, it's important that the students have some moments in which they can, also the youngest one, in which they can research and generate solutions independently. It's also a great way to motivate them, to let them understand that they are able to find solutions by themselves, and not only to find solutions generated from other people. That's why it's so important. And it's the same goal that's in the STEAM lesson and the project-based learning lesson. Also, that's why they are really useful together. Another really important point is the second one. That, of course, so the questions are driven by the learners, by the students. And we are going to see also here many possibilities when we are going to talk about the questions or the problem to solve. But here it's really, really important to outline that the failure is an integrated part of the learning process. That's also important. The students know it's in advance, that they can fail, and that it's not just a mistake, but it's a part of the process. And why? Just think about a real world situation when you are going to work in team to find some solution. Of course, it's extremely difficult that you can find the best solution at the first in the first moments, but maybe you will require many times, and you can realize that you can learn also through your failure, and you can learn what didn't work and why, and increase your knowledge. So the failure here in STEAM, in project-based learning, it's integrated part of the learning process. This is really, really important to have it in mind before to plan the lesson, and also to tell this to the students, that they know that they can also make mistakes, but of course they have to use their mistakes to improve their knowledge, to make better final products. So these are the most important point that STEAM and PBL have together. And now to sum up a little bit, we say the students have to solve a real life problem. This is the first point. The second one, the students do researches together and find a solution together. You can do it with the whole classroom. You can do it in small groups, in pairs, so as you wish. It's better not alone or not all the lesson alone, but to have at least some moments in which the student can work together in groups.
Sorry,
and then,
Francesco.
Yes.
So someone asked if you can put it in presentation mode because they cannot read well.
Of course.
Thank you.
Sorry. Better now?
Yep.
Okay. And also the third point, it's really, really important, because we said at the beginning, this is valid both for STEAM and project-based learning approach. That the students shouldn't have previous knowledge on the topic. Of course, you are introducing a new topic in your lesson. In this case, you can do an introduction or not, but you can also let work the students without any previous knowledge on the new topic you're going to introduce. This is the most interesting thing, I think, because in this way, the students are really motivated to research from the beginning and to gain a lot of knowledge independently. Of course, always with your guidance. But it's also an important thing. You can also figure out to address some problem or questions in which, for which the knowledge doesn't have any particular previous knowledge before. And it's also important because in this way, the students have the possibility to use the previous knowledge also from other fields and integrate it with the new knowledge they are going to acquire. So they have the possibility, and it's really a real life, to have both use their previous knowledge or their previous experience and connect it with a new topic and with a real life situation. That's why it's a good challenge. I know it's challenging at the beginning, but also to try to address some problem for which the students don't have the knowledge still to solve it, and let them get the knowledge autonomously, of course, with your support. And then, of course, in project-based learning, and also in STEAM, but with project-based learning, it's really fundamental, that the students are going to present their final product or their solution to an audience, but to a real audience. As you're going to see, analyzing our examples, it's not limited to their classroom, but they should present their solution to a wider audience, wider as possible. For instance, it could be, of course, other classes, the entire school, the parents, or even better, also people they don't know, for instance, on the web, or to use some event, some occasion to present their products to the community. Also, it sounds challenging, I know, but there are many possibilities also to implement this part. And it's really, really important to have always in mind, and also when you are planning a STEAM lesson with project-based learning, also to plan or to try to plan in advance, also with the support of the students, because you will see they will have a lot of good ideas, I'm sure, but some possibility how to share in a wider way as possible their new knowledge or to show their final product in order they're going to be also proud to what they have realized at the end. Okay, and this is like the introduction about project-based learning and its implication by using it with the STEAM approach. And now, of course, we are going to analyze which is the most important point of this method itself, but also the most important connection with the STEAM approach, which is the driving question. So we said at the beginning that that we are going to solve real problems or to address real questions. This fundamental question, which is the start of every lesson with the project-based learning approach, it's called the driving question, because it's the starting point of the entire lesson. And which are the main characteristics of this driving question? And how can we use it in the STEAM approach? This is really, really interesting. We will find a lot of inputs together also. So the first point to outline is so that you should present this driving question as the framework of the entire project. Well, what does it mean? That so this question should allow the students to research in the direction you want they do this research. Yeah, I know that's theoretically speaking, it's not, as I said, it's not easy to understand, not always, but we are going to make some examples to explain this. But of course, when the students are going to do all the activities in your lesson, they should have always in mind this first question, in which they are going to find one or more solutions. And of course, this is connected with the second point, that so a good driving question is a question focusing on all other questions, so behind a solution or a final product. Also here, it's useful to have a little explanation. So that means that the driving question here, so generally speaking, is interdisciplinary. So when you're choosing a driving question as a starting point of the lesson and to deliver your knowledge, you should also think about a question in which more than one subject are involved. And this is also extremely important. Think about not only project-based learning, but think about the STEAM approach. So STEAM is per nature interdisciplinary because it's an integration of different subjects together. And also here, when you are going to select your driving question or questions, it's important to think about which subjects are connected to this question. If we are going to find a solution to this question, which knowledge from different subjects is required? That's also really, really important to know in advance. And of course, connected to this is that a driving question must be open-ended. And this is, we can say, this is like a rule, one of the most important rules. A good driving question is always open-ended, because otherwise it's impossible for the students find like a personal solution or to realize like a product that is different from all other products. For instance, when we talk about the difference between a normal project and the project-based learning, it's when you are doing a normal project, normally you are going also to tell the students what they're going to realize precisely at the end of the lesson. In this case, they must have the possibility to find alternative solutions. Of course, always gaining the knowledge that is required to solve this problem, to answer to this question, but this question should be open-ended enough to allow the personal investigation of the students and different possible outputs. Of course, it must be also a question engaging high-level thinking, which means not only to find a solution of a simple practical problem, but also to a solution that engages different level of thinking, the practical one, the theoretical one, the collaboration, the communication, because you have also to share your results. And all this requires to develop our high-level thinking skills, also, or competencies, also in this case. And of course, it's also really important that this question or this problem require the students to synthesize information. Of course, they are going to do a lot of research, and what means they are going to gain the knowledge by themselves. But of course, their final product should be like a synthesis of all this information. And here, what does it mean? We are going to realize a physical product, then also to evaluate this physical product, you should also have in mind that also external people, external audience, who is going to use this physical product or this presentation or whatever, should understand also which knowledge the students used to produce this final output. So a synthesis of knowledge. Of course, as I said, in this case, in project-based learning, you don't have, it's not mandatory to be the physical product at the end. It could be also a presentation, but through this presentation, for instance, the external audience should be able to get the same knowledge the student used to realize it. Of course, also here, we're going to make some practical example. And of course, it requires the students to use, as we said at the beginning, their personal experience, their previous knowledge on that topic, from other topics, integrating them to realize the new final product with the project-based learning methodology. So these are the main features, the main characteristics of the driving question. But of course, we have to, so first of all, see together some practical examples, and then I will let you try also to do it by yourself. So just to sum up, we can see, just to repeat, because it's an important point of the project-based learning approach, that, sorry, an open-ended, a good driving question must be, first of all, open-ended enough to allow the individual investigation. Second, relevant and meaningful to students. What does it mean? That the students can understand immediately which are the implications of your question. So it's meaningful for them. It's part of their everyday life. Then, of course, should support the self-directed learning, should allow the students to research in different directions. Involves authentic problem solving. That's also fundamental, because of course, the students are going to solve problems, to answer questions by themselves. And these problems or questions should be useful for their everyday lives, so much as possible. And of course, it must be interdisciplinary, as well as the STEAM approach, since we are going to implement this project-based learning together with STEAM. So it's even more important that the driving question contains both art contents and scientific contents. Now, of course, we have a theoretical overview now it's important to focus on some practical examples, because of course, theoretically speaking, it's difficult to understand as a concept. But here we can see together some practical example of driving questions, of project-based learning lessons. Some of them we can connect so directly to STEAM, some other don't. But the point here is to see together which kind of question you can ask, which kind of problem you can propose to the students, and which characteristics they have. For instance, you can choose a driving question which is related with the exploration of a philosophical question or problem. Just consider the first one of this example. When do we grow up? This is, of course, a philosophical question, as you can see, but it involves a lot of subjects together. Just think about it. It involves also biology. Then it involves, of course, philosophy, but it can involve also history because of the different concept of growth. It can involve also economy, a lot of psychology, a lot of different topics together. And just imagine which kind of final products the students can realize to explain the concept of growth. Or the second one, which is also challenging for adults, for ourselves. So who has power and how do they get it? This, of course, this could be a political question, but not only philosophical. You can examine also the history, the implication of the technology used to have and to spread the power of people. A lot of different, it's really interdisciplinary, really allows research in many different directions, and a lot of knowledge of different subjects is involved in this example, for instance. Of course, there is also the other possibility. You can start from an historical event or a time period. Here, there are some examples used so in American schools, of course, but we can also, so for us in Germany, we use, for instance, the second example. So what do we know about life in East Germany before unification? And here, the important is also, and I would like to point out how this question has been formulated. Because so the first part is, what do we know? Maybe this is important to let the student to reflect about their previous knowledge, experience, also their wrong knowledge. It's also important to reflect about this, and then to put the experiences together to start a new research. And also here are involved, of course, the previous experiences of the students, but also many different issues, not only about the history, but also here about the technology, for instance. Technology used so then and now, how it's changed, what are the characteristics of the technology used in that period, in that place, and the difference from now. So a lot of also the society, of course, so, and a lot of topics are involved also in this historical driving quest. Then it could be merely a problem-solving situation. This is the classical way to implement the project-based learning, because project-based learning we can also define as problem-based learning, because you have always to solve some problem and to find alternative and original solution. Just let's focus on the first one, which is this is also interesting because the students in some small towns had really an impact in this case. So how can we improve traffic flow in our city, for instance? Just think about how many implications there are in this question, because here it's a matter of statistics. Also, it involves measurements. It involves also consideration about pollution. So many different subjects together. And also here, how to integrate the arts. You can also integrate the arts. It depends on which kind of final products you're going to realize. For instance, there was a nice example of a school in the United States, small town. The students started from this diving question, and they produced some panels to be shown in their town, and they really improved the traffic flow in their town. So they had a real impact. Of course, this is the best way to do it. It's not always possible, but just have in mind that it's possible to also a small impact. It's important for the students. They have realized something useful and they learn a lot of new things. Or also, it's the second one, it's funny, but just think about also here, there are many different subjects that could be involved. For instance, what should we do about the cold lunches in our school cafeterias? Yes, the first glance, yeah, it's a funny question, but just think about, you have to solve this problem in a practical way. So find out why the lunches are always cold. And so it involves also technology, it involves also logistics, many different subjects also in this case. And just remind that, so related to the last two questions we have analyzed together, they are really connected with the real life of the students. Because the first one is about to improving the traffic and to reduce pollution, maybe, in your city, in your community. And the second one, it's related to your school, to your everyday environment. And that's why are really two good example also to start a new STEAM and project-based learning approach, for instance. Or even more, some other interesting example. Also, these are taken from example from the United States. Of course, we can adapt them. It could be the examination of something controversial. So, I mean, in this case, also some actual issues, some events, or some problem which is discussed in the society in our everyday life that the students are aware of. For instance, also the third one, we can just take the third one as example, is war ever justified? And also here, the students can research independently and find their own answer, if yes or no, and why, for instance. And yes, our topic also important in the everyday life that they hear so news every day about this this topic, and of course they are aware that there is a problem in our everyday life, for instance. Or of course, perfect to be connected with the STEAM approach. You can challenge your students. Challenge the students is also, in my experience, a great idea to let them motivated. Challenge them to design or to create something, a physical product to be shown. For instance, the first one is also part of the project we also have implemented with an Italian school. How can we create a mural that represents our communities past and present? Also here, yeah, of course, the arts, so as you can imagine, of course, they're a really important role, but not only, because you have to select the place, you have also to divide the surface in different areas, to measure it, to choose which are the main events, so to research about history, to also to carry out interviews. There are really a lot of different tasks and activities and knowledge also involved. And it's about your community, the community of your students. Also, in this case, it's really interesting. And it's a good way to connect the history, the main history of your country or of Europe or the world with the history of your community, also with the recent one. For instance, also in this way, the students are not only realizing something, they are going to be proud at the end. Every people passing through this street can see their paintings, but also they will so connect the knowledge and the knowledge about their community with other events on the entire world, for instance. Or another, also the second one is really interesting. How can we design a website to share our poetry with the world? Here, that's really challenging because it involves different interests also of the student. Because design a website, they should design a website, but with a specific aim. So here, it's a really STEAM activity, this, because here you are involved with the web design, so which is really important. When you're going to also to open an activity, you're going to create the website. It's really important. Also, the layout of the website itself, the user to be user friendly, and also connected with here random subject, but here poetry could be sorry, other subjects. So how to promote one subject through a website, for instance, and they have to realize many different things in this case. Or even how can run a successful book club so at our school? So do a brainstorming, see different ideas, different opinions, if it's useful or not, and how can be also become more useful or for other people who are not interested. So many different, as you can see, with the driving question, you can ask to the students really many different things, really in an interdisciplinary way, allowing them researching in different directions. I hope that this example can be useful for you. Of course, I would like, so before to do our activity, our short activity, I would like, for instance, to tell you about another real example. Also, this we did it in a school here in Germany, here in Berlin, and it was a project-based learning lesson. It was a long one, like about 2 months, and the question was how can we reduce the spread of viruses in our school? And of course, also here, the final output that the students choose to realize were also some panels to be shown in the school. And it was really engaging because they research about viruses, about their spread and so on. And also they realize something practical, and they share their knowledge to the entire school, but in a usable way. Because of course, there are so many instructions, useful instructions, that every people could read and use to avoid the spread of viruses, for instance. So this is just to outline the main point. If the students can realize something that is meaningful, so useful for them, is of course one of the best way to motivate them. And of course, now we can do a short activity. I would ask you to take 5 minutes to write at least 2 driving questions with the characteristic we have outlined before. I can come back to our slide. You can have a look at this slide and just think about your subject and at least another one, and try to formulate 2 driving questions with the characteristics described here. We have talked about. Just take it 5 minutes to do these activities, and then we will move on to the next topic.
Francesco, Caterina
Yes.
asked if they can write it on any topic that they want.
Yes, exactly. They can write so it's on any topic. The important thing is so to connect at least two different subjects together. Then you are free to choose any topic you want. Of course, it's useful to think about maybe your students, your classroom, one of your classroom, and maybe to think about the interest of the students and try to put them together to two different subjects, school subjects.
Thank you, Francesco. Caterina, I hope that that has been your question.
Okay. Do we have to share the question here right now? No, it's not. It's just for you, just to give you some time to think about a couple of questions can be useful for you to use in class, and of course we will have the possibility to use them in the second part of the activity, but you don't have to share them now. And here there is Caterina sent in the chat another interesting, really nice question. How much do you know about the history of your school, for instance? Yes, that's really nice. Yeah, should we remove weeds from the fields? That's a really perfect. I really have a really nice example of driving questions. Of course, if you would like, you can also write them in the chat, also for the other, if you would like, but it not matter. They are so really nice example. Thank you very much. Sorry. Just take another minute or two to formulate your question, and then we will move on to the second part of the training. Oh, I see. So many. Now I put the chart in the share screen. Many useful and really nice driving questions. Perfect. I'm really happy. These are all really good examples, good start in driving question because they are all related to the real life of the students. They can have an impact. For instance, so how can we reduce our plastic waste at school, for instance, or how can we be safe online? Also, really, what is cyberbullying? That's really good example. Perfect. That you can really share and use with your students also in different classes from different grades. That's excellent. Perfect. Thank you very much. Of course, you can continue so this activity and find out many different driving questions. So starting with a really good example, some of you have to share in the chat. So thank you again for this. And then, of course, we are going to talk about another teaching a learning methodology connected, very well connected with the STEAM approach, which is the design thinking process. Of course, also the design thinking is, so we will see, it's interesting also to point out that design thinking has so many features in common also with project-based learning, but with some difference, of course, we are going to see. And I can anticipate you can also use your driving questions, and also you can use also the solution found by the students to this question to implement a second activity with design thinking. So that's why it was important to write also for you some driving question you can use also in the second part of the activity. But of course, what is design thinking process? Yes, because here we are talking about a process or a method, but both definitions are, let's say, allowed. But I prefer design thinking process because here it's about a process of development, and we can define design thinking in this way. Design thinking, of course, you can understand it by the name. It's a design methodology. Design, of course, in general, not only a physical design, but also a project design methodology that provides a design-based approach to solving problems. Here you can also understand what is behind this methodology. It's design-based approach, which means I'm solving a problem. In which way? By realizing a new product, which is going to solve the problem. This is really interesting also for the student. In this case, a physical product. In design thinking, of course, it's really a powerful approach to get students to think both critically and creatively. Of course, it's fundamental in this case because the creativity is fundamental here because the students are going to produce something new, to build something new. But of course, this product should help to solve one problem. And for this, of course, you have to develop your critical thinking to find solution and to create something, to create some final product that is addressing this solution. Of course, in this case, the design thinking, similar to STEAM, because you remember, also in STEAM, we can identify different steps. In the design thinking, the steps are integrated part of the methodology. So that's why, sorry, here we are going to use a structured framework, structured methodology with steps in order to identify which challenges the students are going to face to solve the problem. Also here, in this case, to get the information, the new knowledge the students need to solve the problem, to realize the final products, and to generate the potential solutions. And then also here, we are going to see it's really interesting about this approach. The students have the possibility, or also they should refine their ideas, and they should test their solution and their final product. These are really, as you can see, also here, it's extremely real-life approach, and it also allows the students to connect many different fields and to connect theory and practice in a greater way, because they have to realize something according to the theory, the knowledge they've got at the beginning of the process. Of course, also here, it's a method, it's a powerful method to foster the problem-solving skills. Because also here, we have a problem, we are starting from a problem, and we have to build something which could be the solution, also in part, but the solution to this problem. So it's extremely problem-solving, as well as STEAM itself. And of course, also here requires observation skills, teamwork, because here it's fundamental to be carried out in teams, as in the real life, and also design practical skills to realize these physical products. So it's also interesting to say, also to the students, that the design thinking process is used in many, many different companies in the world to improve or realize new products. It's, for example, it's used also in car engineering, car design, for instance, also here in Germany. And so they will use, the students will use a real methodology approach to, in the same way as it's used so in the everyday life of many different professionals, to generate useful solutions. And also here you can see the connection between the design thinking and the STEAM. Also, that's why they are really, really useful to be used together, because of course, design thinking is so about to develop the creativity of the students, and of course, the same is in STEAM, and also you can connect real world problem. So similarly as we did together with the driving question, solving to solve problem of the classroom environment, for instance, or the school environment. What we are going to do also now, and also like STEAM, also in design thinking, the connection between the real life problems and the solution are visible. And this is really, really important also for the students to know. And these are also the key points we can say of design thinking, what the students are going to develop by using this methodology. Of course, the first one, and really, really important, is the empathy in two different ways. Of course, the first one that you can understand also without previous knowledge of the method, but of course, if they are working in teams, they have to also develop the social skills, not only the communication, the collaboration, but also the social skills, so the capacity to help the other member of the teams to find a solution together, for instance. But also for another reason we are going to explain in a while. Then, this is really important, promoting initiative. So one of the most important soft skills, in my opinion, is initiative. So the capacity to take decision independently. So the students have the possibility to decide here which kind of final product they can realize and how this final product will be useful for other people. Of course, the creativity, as we said, and also it's really important to develop metacognitive awareness. What does it mean? To connect theory and practice in this case. You will connect the theory, the knowledge, with something physical and usable. And of course, it fosters also active problem solving for the same reason, because they are going to be actively engaged in solve this problem and find this solution. Before to go deeper and to explain how does it work, I will suggest you to do like a 5 minutes break, really 5 minutes. So you can rest a bit and you can focus on what we said at the beginning, and then we will analyze the design thinking process, and we will move on with the second activity, which is going to be much more complex than the previous one. That's why it's a good idea to have just 5 minutes break from now. It's okay? So we can also stop the recording for just 5 minutes, and at 12:25 we can move on with the second part, with the last 40 minutes, let's say.
Okay, perfect.
Okay.
See you all in 5 minutes.
Okay, hi everybody. We can start again. Everybody is there. Okay, I just resume the recording, and now, of course, as we said, we can talk about more in depth about the design thinking process. I'm sharing the screen again. Okay, so here we are. Here we can have an overview about the different steps of the design thinking process. Because as we said, also in STEAM, we had 6 steps to follow, but there is a difference in this case. Because when we are going to use the design thinking project in the STEAM lesson, we should use all the steps we are going to describe, because they are integrated part of the methodology itself. While in STEAM, the 6 steps are just a support you can use or not by planning your lesson. In this case, they are an integrated part. And we can start from the beginning. So how does it work, this methodology? This is really interesting. So we said at the beginning that the aims of the design thinking process are first to find new solutions, new products, to design new products, and to improve existing products, or to change their focus, their target groups. So improving and creating. And of course, this is also in this slide, you can see also how this methodology is working in the real life. So also in companies, they use also these steps, as we are going to describe them. And of course, they are all logical steps. So the division, of course, is not casual, but it has the aim of create a new product in the best way. So it's important also to follow this order of steps when planning a lesson with design thinking, with one exception, as we are going to see. The first 2 steps can be also changed. You can have the second in the first place and opposite. But for the rest, the steps are this, in this order, as we are going to describe. So let's start with the first one. Of course, you have, as first, similar to the project-based learning approach, to define the problem. So what is the problem you are going to solve? What problem are you going to solve? Or which solution you are going to find, for instance. So this is the definition of the problem. And also it's useful to do it with the students, for instance, through a brainstorming session. And then to observe the problem. So what does it mean? So you have now defined the problem, and then you have to find out what information, with which kind of information, which kind of knowledge you need to solve the problem, to find new solution. Of course, always having in mind, here it's about creating physical products. So which kind of knowledge I need to realize this physical product to solve the problem. Then there is the second phase, which is called empathizing. And here, as you can see, we can also have it in as first step and not as second. It depends, of course, on the kind of problem addressed. But here, for instance, after you have defined the problem and the knowledge you need to solve it, here it's about to think about the final users, your target group. You are going to realize a new product, okay, and now we have to define for which target group this product is addressed, and which are the needs of the target group, of course, which problem are going to solve for the target groups through this product. This is the empathize phase. And then after you have defined the problem, the knowledge, and your target group, and also here it's always important to focus on the target group, because at the end, also in the educational activity, this product will be really used by a target group. Then there is the drafting phase or visualizing phase. So now that we have this information, we can do some drafts and generate some ideas or some potential solution for our target groups. And here, of course, it's like another brainstorming session. For instance, which kind of products we can realize for our target group, which are the best one, most suitable, or which potential solution we can find for our problem, through which different products. We can do some drafts from now on, and then select the best draft to be realized at the end. And here we have, of course, the fourth phase. So here is the prototyping phase, create prototypes. After you have selected your draft, your best draft, or draft you think it's the best one to solve the initial problem, you can create it. It depends on how much time you have. You can create one draft, one prototype, sorry, or many different prototypes, and to address different needs. But anyway, here is the creative phase, in which the students are going to make something to realize their physical and useful products. And then there is the fifth phase. This is also the difference, because the other phases, yes, are more specific and different from the steps of the STEAM and also the process of the project-based learning, but you can see many similarities. In this case, we have something new, because we have the testing and refine phase. And here, like in the real life, after you have created the prototype, you have to test it. So to use it, your target group can test, they must test this product, give feedback, and then the creator of this product should refine their creation, including the feedback from the test, as well as in the real life by a creation of prototypes. It's also the same process in many car designers. You make the prototype, then you test it, and you include the different improvements. This is also, think about it, so it's really important for the students, because we said at the beginning, similarly to the project-based learning and also for STEAM, because here it's like a process in which you are learning also through failure, through mistakes. Because also in the real life, of course, why you are going to test some products? Because without the testing, you are not aware of the possible mistakes, or if the product is not suitable for its scope, for instance. That's why it's important that the student also understand this concept, that they are going to try to test, and they are going to improve their knowledge, and that this is normal. It's a normal process, not like just a mistake, but it's a starting point to make something better. And it's also necessary, because there are no products that are perfect from the first prototype. It's impossible. Sometimes you have to create many different prototypes to give a good final product at the end. So that's why it's really important for the students. And of course, it's perfect for STEAM, because you include so the theoretical knowledge with something practical, something creative to be realized at the end, but through a specific and logical process of steps, for instance. And now, of course, the question could be, that's really interesting, but how can we use it in practice with our students? And that's also one of the aim of this training, because it's also connected with our Space Lab project and with one of the main output of the project. This is so just to introduce it briefly. This activity we are going to explain is an activity we are using. So in the last years in our training center for the STEAM training courses, and it's really useful also for the objective of the Space Lab project, and to implement STEAM in really every kind of grade of students. That's why we will describe this activity in detail, and I would like that you will try also this activity with your students or with other teachers in your school, because you will see it will be really engaging for both. And so, as said, so how can we implement this this method, this methodology in a practical way in our school? In this way, by designing, for instance, a board game. Just think about it. In the board game, you have a lot of different inputs, and you can include a lot of different activities, also related to the design thinking methodology. And why, for instance? Let's go back a bit to the steps. Also here, you can see the board game. Board game is so something engaging for the students, because it's a game, but of course, but also because the students can have the possibility to design and improve a game. Sorry. And now we can connect it with our learning process, with the content knowledge we would like to deliver. And for instance, we are going to do a STEAM lesson. So at least one scientific and one art content together, and the design thinking process. So we have to create something related to these at least two subjects. You can just imagine the board game is a perfect activity, because of course it's engaging by itself for the students, but through a game you can learn and research a lot of things just by defining the objective of the game, the content knowledge to deliver, and also the gameplay itself. For instance, we can start to, after we have given to the students our learning objectives. So, for instance, which content knowledge we have to deliver through this board game, then we can start to adapt the different steps of the design thinking to our board game activity. Let's start from observing. So here, for instance, you are going to design a board game you can divide the students into groups, because it's always important to point out that design thinking is a group activity. And each group here can brainstorm which of the already existing board games is, for instance, most engaging, and for other students, for the target group, and best suitable for giving the content knowledge to this potential target group. So they can do this brainstorming and put together many different board games and select the most engaging and the most suitable to deliver content knowledge. In this case, I said at the beginning that we can also go first with the second step, with empathize, because of course here you can also decide to carry out the second step as first, because in a board game you have to decide which is the target group. For instance, we can make an example. We are doing it so many times that older students are designing board games for younger students. So as first, you can select, in this case, your target group, and also you can analyze the needs of the target group. For instance, you have to include at least 2 subjects. You can include 2 subjects or 2 topics from different subjects with which the younger students have difficulties. And then after you have make some interviews with your target group, because it's also important to, when it's possible, to have some interviews with some member of the target group. For instance, in this case, let's say the younger students. The older students can collect their feedback, can, for instance, can know which kind of board games are more engaging for them, for the target group, and which are the topics at school with which they are struggling at most. With this information, they can better define their problem. So the problem to solve is first to create an engaging board game connected with this content knowledge, the topics. And second, to define which are the learning problem of the target groups. So why the younger students, for instance, are struggling at most with these 2 or 3 topics. Why they are so difficult for them. After discussing it, also with the help of the teacher, the students can come back to their groups of work and move on with the third step. So visualize and draft. And here the students can draft some ideas of different board games. So starting from the existing ones, analyzing, for instance, the gameplay, in which ways can we improve this board game, and we can adapt this board game to deliver this content knowledge. And also, the students can also get inspiration from existing board games, but create games which are so completely new. Of course, inspired by 1 or more existing games, put them together. Here it's also a funny activity for the student, because they can have a lot of ideas, create really new games starting from many different ideas, and then try to adapt them to deliver the content knowledge through challenges, for instance. There are many different ways to, of course, to draft new games. The students can now, for instance, draw some drafts, sketch some rules, different ones, and then, as we said at the beginning, related to the third phase, to visualize, the groups can do another brainstorming now to select from the different proposals of board games, which is the best for delivering the content and the most engaging for the target group. And now, of course, there is also the one of the most engaging and funny phases, which is, of course, the creation of a prototype. Because here, each working group is going to build a prototype of board game. Of course, also in this case, there are a lot of different tools, ICT tools, programs, physical ones, you can use with your students to build up prototypes. For instance, 3D printers or whatever. Really a plenty, an infinity of them. Actually, what I suggest, of course, there are always all good ideas, but what I suggest to start with these activities is to use just scrap materials. It's what we are doing normally with the schools also here in Germany. And it's really nice activities because you can just put in front of the students a box with many scrap materials, so cartoons, packaging, milk containers, so whatever, bottles, whatever you want. So really waste. That is also the nice thing. Then we can take some waste, some scrap materials. The student, you have, so all of us have a plenty of it at school or at home. The student can bring their own from home. You can use that one you have at school and transform it. So give them like a new life. This is one of the thing I prefer also of these activities. So to use this waste materials, scrap materials, and use them to create something useful, something also nice for other students, and also helping your creativity because you have to use these materials to build your game. To use also a nice game, a well-looking prototype, because it's part of the activity. It's an integrated part also. The design, the physical design of the game, also to be evaluated in the end, and also to be creative using this material to create the best prototype possible. And also, you also improve a lot the collaboration of the students because you are collecting many materials together, and the students they have but to divide them into the different groups. It's a nice activity also if you are putting a box in the middle of the class, and the different group of students together are deciding by themselves which material they can take, they can share also to the other groups. That's why I like to suggest this way to start our design thinking board game using this waste and scrap materials. But of course, now the students are going to build the game according to the best draft they have selected. And of course, as I said, really important here is the layout, is also the physical appearance of the game, because you should, yes, of course, deliver knowledge, but in a funny and a nice way. So you have to build a nice board game. It must be also the design is really, really important. Also in the real life, it's also well connected with the real life because when you're designing a new product, also the physical design, the appearance is really important to sell it also. Also for the target group, the students also must think about which is the best design. Of course, with the material they have, this is really creative, I think, the best design for their target group. And also the gameplay, of course, it's fundamental here, since it's a game and the target group have to play it, to have fun also. It's really important to write the rules of the game really carefully. To build the material, of course, in a nice and a useful way, which is user-friendly too, and to write the rule in a clear way. It's also a good idea to test, to have a pre-test phase in the group itself, really short one, before to test the game with the final target group. But it's important that in the prototyping phase, all materials needed to play should be produced. So all materials needed. The prototype should be completed and usable. Of course, also here, the students will, with the help of the teacher, of course, will find the different strategies to include the content knowledge, which is the focus of the lesson, of the STEAM lesson, to, for instance, the younger students. Of course, I'm always talking about younger students because it's like, I think, a good example to understand how it works, but they can do the same. So the different group from the different class, sorry, for the same class, they can do the same for other groups. For instance, there is a group of people which is struggling with one particular topic, another group of students which is good at it can design a game for the other classmates, for instance. There are many possibilities, but just to be simple, I'm using this example of the younger students. But anyway, after that, after you have created your prototype with all of its elements and the rules, of course, then the target group should play here and test the game. What does it mean? Here, it's a good idea also to write like a grid, a rubric for the testing. And in this rubric include also the content knowledge. For instance, when the group of younger students is testing the game, then as a feedback, they should write or tell what new content knowledge they learn through the game. This is fundamental because in this way, the other student who has created the game and the teacher can refine together the gameplay in such a way to include in the best way the content knowledge to deliver. And of course, here it's important to, when after the testing phase, to have like a set of questions that the students who has created the game should answer in order to improve, to build a new version of the game. And this question could be, for instance, but a really simple one. So, for instance, can the gameplay be improved? So the younger students find some difficulties in the gameplay, or it was boring for them. For instance, the first one can be more engaging, or does the game facilitate the learning, and so on. Just simple question in order to make some improvement. And then, of course, here is one of the most important points of the design thinking approach, is to incorporate the feedback in the final product. So to build an improved version of the game, including the feedback of the testing phase. So the students can learn and play in the same way, and the creator of the game, they have learned a lot of content, because maybe, or surely, they should also do some research about the content to be delivered in order to also select the best topics to be included in the game. So include a research phase also here about the content knowledge, and also, which is important for the students, is a way in which they can deliver content knowledge different from like a presentation. This is difficult for many students, for instance. In this way, it's an engaging way to deliver your knowledge, to refine and deliver your knowledge to other students. So as you can see, it is a perfect activity for the STEAM class, because of course it's highly engaging, but you can foster your creativity. It's already hands-on. Also in STEAM, this is important. It's a hand-on approach. And also design thinking is extremely hands-on methodology. And you can, for instance, when we're talking about the board game, you can modify it easily according to every age and grade of the students, changing the gameplay or the content knowledge, making it more easier or more difficult, depending on the target group, for instance, on the topics you would like to learn through the game. And as you can see, it's a perfect way, the board game, to include really countless of topics and subjects in one lesson. So it's really interdisciplinary and really STEAM. Okay, and of course you can find a detailed description also of how to build a board game with the design thinking approach in our handout, which you can also find in the website of Space Lab. You can download it for free, and there is a detailed explanation also of the project-based learning methodology, as we did before, the driving question activity with some other examples, and also the detailed description of the different phases of the board, the creation of the board game with the design thinking. Okay, so unfortunately, our time was short, but so I hope it was so useful for you to attend our online training. Here, as the last slide, just some inputs you can use by implementing the design thinking with your students. Of course, now we can have a short Q&A session if you would like to ask whatever you want about the project-based learning, design thinking, STEAM in general, or doubts you have by implementing these activities, suggestions. So whatever you want, let's have like 5-10 minutes session. Now I'm stop sharing the screen. I would like to remind you, of course, that on the website of Space Lab, you will find not only the handout, but also the slides I'm showing you now, and also other slides that you can always use, of course. Also, if you would like to do this activity with other teachers and students in your school. So, and of course, if you have questions, you can always come back to me. I will write also my email in the chat at the end. And of course, feel free to write at every moment, because also for us, it's really an important approach, an important project. And if we can help with this, we are really help. Katerina is asking, okay, where we can find also the recording of this session.
Okay.
Okay.
So basically, now the session will end. Will be shared. I'm not totally sure, but like we definitely can share it like with whoever needs it, and probably. I mean, I have to double check with my coordinator, but yeah, we can also probably share it with all of you, all the participants, so everyone has it to rewatch it, to use it if they need it. So don't worry, will be shared.
Thank you. So if you have some question, of course, also general one, specific as you wish. Daniela is writing failure. Nice. Because how to manage it? Okay, how to manage failure? This is a really good question. Thank you, Daniela. Because of course, here I would like to focus on the design thinking process again. How to manage failure? Because we have to tell our students that we are going to test every single product we are going to realize also in our learning process. For instance, if you are making this, yeah, let's say also in normal exercise, mathematics or whatever, you are making mistakes. This is not a problem, because you can use, this is part of the independent approach, on a student-centered approach. The students receive a different kind of feedback. You don't call it mistake, call it, it's an opportunity. Okay, something is not working. It's not a problem. Now let's identify together with the teacher and also with the other student what is not working, giving some suggestions. This is valid for simple exercises of activity or more complex tasks like the board game. For instance, in the testing phase, we receive the feedback of the students. Okay, it's not so much engaging. And the student must be aware that it's not a problem. This is, of course, a test, a prototype, not a final version. Okay, now let's analyze why it's not engaging enough and in which ways. And we can do it, of course, by empathizing, by interviewing our target group of students or our target group in general, and including these feedbacks. So that's why it's really important the students know that they are not going to fail, but just to do it again, to improve. It's not a failure, but an improvement. And all steps are designed to improve something in product. You can also make them the same example I did with the car design. How many prototypes are designed before to realize the car to be sold on the market? A lot, really a lot. That's because it's impossible that for every single person, it's impossible to realize something that is perfect from the beginning, but you have always to try again, and to identify the shortcomings, to identify the difficulties. And you can also justify it with the students, because you can also justify it in this way. When you are not identifying your difficulties or the difficulties of other people, you can't solve problems. If you would like to solve problems, you have to fail. Otherwise, it's impossible. And you have also to try and try again. Otherwise, you can't be aware of your difficulties. So I hope, Daniela, to also in a short time, I'm sorry, because it's a really big and interesting topic, but to at least in part, I've answered to your question. Thank you very much. There are other questions or comments? Okay, then if there are no more questions. Oh, sorry.
No, I just like before to end the record and the Zoom call, I would just like to remember to all the participants the next appointments, just as a reminder. So for Italy, it will be tomorrow, so the 5th of April, from 5 p.m. to 7 p.m. Central European Time. Greece and Cyprus, the 6th of April, from 1:30 p.m. to 3:30 p.m. again Central European Time. And for Spain, it's the 11th of April, so next week, from 4 p.m. to 6 p.m. again Central European Time. And another thing, we got an answer. Like, yeah, the recording will be shared with all the participants and also who missed this appointment via email in the following days.
Okay, thank you. That's important information.
Yeah,
very much. And yeah, really useful also for our participants today. So if you don't have other questions or comments, I would like to thank you very much for your participation. And really, because I know the training online are more and more difficult, much more difficult to follow. And that's the face-to-face one in my experience. So thank you for your patience. And I really hope to that you can really use some or all the methods and strategies we talk about. So as I said, you can find everything also, and also the recording, but also all materials created specifically for this training in the website of Space Lab. And of course, you can always come back to me for any kind of question related to the STEAM education and the different methodologies that we use and we briefly analyzed together. So thank you again. So have a nice day, everybody. And thank you for your attention. Bye.
Bye-bye. Thank you, everybody.